Hello and welcome back, and in today's video I will be talking about how to process the uranium ore from its natural mineral state into a uranium metal that can be used in applications such as nuclear weapons, power plants, and etc. As a disclaimer, do not replicate anything that you see in this presentation. All the information that I provide in this video is purely for educational purposes only. The dangers of radioactivity are very serious and should not be toyed with. I, the author of this presentation, have zero responsibility for what you do with this information. Any injuries, harm, death, or anything similar that result from application of the information in this video is not my responsibility. And with that aside, let's first get into what exactly uranium is. The interesting isotopes of uranium for isolation in this presentation, it's mainly uranium-235, which can be used in nuclear weapons, but there are a few other isotopes of uranium, notably 234, 235, and 238. 238 is fertile, while 235 is fissionable. The most common one in the Earth's crust is going to be uranium-238, but usually if you want to make something more exciting with uranium, you will need to somehow enrich the uranium ore that you get to isolate that uranium-235 section, which is about 7,200 parts per million of natural uranium ore. Now, uranium can be used for a lot of things, such as nuclear power plants and nuclear weapons. And the main place that people are going to be getting uranium ore from, like the actual uranium ore, is going to be uranite, also known as pitchblende, as well as coffinite. Coffinite is a silicate mineral, and uranite is mainly just made up of uranium dioxide with other impurities added in it. Uraninite is the primary ore, and I'll be talking about it in this presentation because it's relatively simple to process. And on the Earth, uranium naturally deposits quite easily because it is very soluble in water. Uranium salts, uranium compounds are quite soluble in water. So they're easily dissolved and transported and moved around the Earth through groundwater. And this is how you can form deposits of uranium ore. You can usually find high-grade uranium deposits in a lot of places. Just one example I picked out was the Athabasca Basin, which is in Canada. Now, uranium ore needs to be mined from the Earth, and this is done in a fashion typical of a lot of minerals. In this case, it is chemical leaching. Chemical leaching is pretty often used. And this is the process by which you pump chemicals into a well, and these will dissolve the minerals directly out of the earth. And typically you'll use sulfuric acid for uranium extraction because it's relatively cheap, it's simple. You can get sulfuric acid as a drain cleaner, and it's really not that expensive. And this uranium, the actual reaction that it's undergoing is an oxidation, and this needs to be done through some oxidizing agent. This can be done with iron salts, chloride ions, or manganese dioxide, and the reaction is shown on the screen. And after it is oxidized, it reacts with sulfuric acid to form the uranyl sulfate molecule. And this is the molecule that will actually be pumped out of the wells and extracted. And this extraction is done through solvent extraction. So typically hydrocarbon solvents will be used for this, and just some examples of some hydrocarbon solvents that can be used. I would say alkyl phosphoric acids and secondary or tertiary alkylamines. These will dissolve the uranyl sulfate, and you can extract the solvents out and to isolate the uranyl sulfate. And to go from the uranyl sulfate ion to yellow cake, you have to precipitate it out. Right now it exists in solution as a ion, but it's typically more useful if you can precipitate it out in what's known as yellow cake. You might have heard of this before on the news. Yellow cake is typically just ammonium diuranate. It's a yellow powder, and this is made by adding some sort of base to the mixture of uranyl sulfate. So usually sodium hydroxide or aqueous ammonia is used. Ammonia is more popular because it's really cheap. It's this process is quite simple. So ammonia is just generally more popular because it will yield ammonium diuranate, which is convenient for the following steps. Unfortunately, right now this yellow cake is actually quite crude. So in order to make a certain grade of uranium, the crude yellow cake has to be refined. So this is done by first dissolving the yellow cake in nitric acid. So this will yield uranyl nitrate, and after you do this, you add in some tributyl phosphate, which is diluted with kerosene or some other hydrocarbon. And you do this because the uranyl nitrate is very soluble in the tributyl phosphate. So when you mix it in this solution, you will be able to extract this uranyl nitrate. And once you evaporate off the solvents, you will get very pure uranyl nitrate. On the screen, you can see ammonium diuranate and tributyl phosphate. Ammonium diuranate will be right here, and tributyl phosphate will be right here. Now, of course, even once you manage to refine your yellow cake, you will still need to enrich this uranium that you have. And unfortunately, there's not that much information out there on the exact enrichment process, specifically on how to convert the uranyl nitrate into uranium dioxide. So I did my own research on this. I found a few papers, and they seem to suggest that when uranyl nitrate is calcined, it will form triuranium octoxide, and the reaction is shown here. Unfortunately, I could not find any verification for this reaction other than that one paper, so try this at your own risk. Well, do not actually try this. So once you calcine it, so you put this under very high temperatures, this will release the nitrogen dioxide and some oxygen gas, but it will leave behind triuranium octoxide, and this can be reduced with hydrogen gas, and this will yield uranium dioxide. And uranium dioxide is very convenient because you can now react with hydrogen fluoride gas to produce uranium tetrafluoride, and this will be done in a fluidized bed reactor. So you can go from the tetrafluoride to the hexafluoride by reacting it again, but this time with fluorine gas, and this will create uranium hexafluoride. Uranium hexafluoride is great for enrichment because it's very volatile. So you can process this through a gas centrifuge to isolate the uranium-235, and you can also fractionally distill it to concentrate down this uranium hexafluoride. It's also quite convenient to store inside big drums. I believe most uranium will be transported as the hexafluoride or the yellow cake, but I'm not exactly sure about that. And actually, to go from the uranium metal, to produce uranium metal, there's this process called the Ames process, and this process reduces the uranium tetrafluoride with magnesium metal at a really high temperature, and it's just a simple single displacement reaction, and this will produce uranium metal. It's going from the plus 4 states to the elemental states, so it's a reduction, and this will produce the uranium metal, which you can then use to make nuclear fuels. Well, typically nuclear fuels will be kept in ceramic form, but you can use this uranium metal for various purposes. I guess you could use it to make nuclear weapons, but this also makes magnesium fluoride. With that said, that is the end of the video. I hope you enjoyed this video, and I hope you have a great rest of your day now that you know how to process uranium ore. There might be a follow-up video showing how to do this with common household chemicals. Without further ado, have a nice day, and I'll see you next time.